This conference will now be recorded.
Okay, so good morning all and welcome back to the session that is Big Data Masters program. And guys, we are going through with distributed processing with PySpark module. In the previous session, what we have discussed about the data write mode, how to write the outcome, and over there we have gone through with standard data write API. We were having a particular data frame and we were trying to write it in CSV format, and there are certain clauses like write, path, option, format, and we have utilized these particular things. And what I have mentioned like partition by, bucket by, compression, these are the things that we will uh, learn in our upcoming sessions. So today we will focus on to these particular aspects. Apart from this, what we have seen like how to do the aggregation, we have gone through with group by and certain aggregation functions. So that we have covered. I have given you an assignment as well, and like to uh, change this particular to get the outcome in that to like work onto this particular data set and get the outcome in this particular desired format, so probably some of you have worked onto this and they are able to get the outcome. Those who have not tested, please try to work on it. I have given you an assignment as well, so try to complete that particular assignment by EOB and share it by tomorrow. So we can move further then, so with respect to this particular use case, this particular approach was suggested like take two columns and convert those particular columns into RDD, then do the splitting, and then convert it into the DF, and then join both of those DF, so try to do this. If you are not able to do, like I'm going to start a particular new series and onto the YouTube channel, over here one new series will be there, that is interview and interview preparation. Basically over there you will get the answer for those particular problems or assignment that I have shared, so slowly over here you will get the solutions of all the problems that I used to share with you all. So let's move further with the agenda for the day, and we will start from the standard data write API. And what we know from the Spark side, like there are three main things that we are going to perform, like reading data, then processing data, and getting the outcome, or writing the outcome. So data routing output, or outcome, that is both of these are the same things, so reading data, we have seen the standard data read API. Then processing, over here like we have gone through with certain how to handle the missing data or data uh, aggregation related stuff we have seen over here. We will focus on to the processing part as well, but we will start the day with writing the output. And for this, like what I'm going to have, I'm having a particular data set, Titanic. This is very famous data set that we are having. So let me try to read data like test.csv file, and then we will try to write it, and we will try to utilize different clauses like partition, bucket, and compression. Those particular things we are going to learn in detail. So I have created a particular week 11, day 16 uh, Python file over here, and let me try to import, or let me try to have the Spark session over here. So say week 11 day 16. This is the Spark session for the day. And let me remove these particular things. These are not required as of now. So we have created the Spark session. Now let me try to read the data with standard data read API. Okay, so with this particular standard data read API, let me try to pick it, paste it over here, and it will be say test data frame. So test data frame, and the location for this particular data frame is this one. So let me copy and paste the same over here, and test.csv. Okay. So this is the data set that I'm having, and we will try to move with this particular data set and just have a look. This is the path, and I have loaded it. Now let me try to print 10 records. Let me give you the feel of this particular data set. Sure. And I'm running it.
Sir,
Mm-hmm.
I, I only see the notepad. I don't see the pie chart. Are you sharing that screen as well?
Yes, yes, I have shared. Is it same with everyone? Are you able to see my screen? All of you?
Yes, that is fine.
Yes, sir.
Yes, yes, sir, it's fine.
Okay.
Okay. It's visible, huh? Right? Okay, okay. So I think you need to relog in, huh?
Yes, your screen
So
is
just
visible, but are you working on PyCharm or on Notepad?
PyCharm, huh?
Okay, I'll exit and join again.
Guys, are you able to see PyCharm ID?
Yes, sir.
Okay, okay, perfect. So just have a look. This is the test data frame that we are having, and we have read it. So what we have seen over here, like this is a data set that is in CSV format, and we have utilized the standard data read API. We are able to read the data. Okay, that is fine. Now, what I'm going to see, like this is a data frame that I'm having. Now, I want to use, I want to get the insight of standard data write API. So I just want to write this particular data frame, test data frame dot write, and with respect to the data write API, let me copy and paste from here. So the test data frame dot write, and I want to write this particular data frame, and the format that will be CSV header true mode override. Let me try to copy and paste it over here, and do a little bit formatting as well. Okay, so I'm going to write this particular data frame, and the location, let it be this particular location, Titanic only, and let me mention over here Titanic, and say output. This is the folder or directory that I'm going to create in order to save the output. And like once I'm going to run this particular code, what it will do, it is going to write the test data frame onto this particular location. That is fine. Let me run it, and then we will see it. Over here we will be having a particular folder named output, and in the output we will be having uh, the test data frame. So the execution has been done, and just have a look. We are having this particular outcome, and that is nothing but like the data which is available inside test.csv. We have done nothing over here, just we have read a particular CSV file, and with onto that particular CSV file, we like over here the processing phase is there. Say processing data, we are not like doing any processing over here, because we just want to go with the data write API. Yeah? And standard data write API over here, but we are having standard data read API. Okay, so these are the three things what we are having in a particular uh, PySpark code read API. So with this, we are able to write the outcome onto the location that we have mentioned. But over here, first we will go through with the mode. Over here, what we are able to see mode. In PySpark, friends, we are having four write modes, write modes. So there are four write modes in PySpark. Let me mention. First one is overwrite. Once we are having overwrite mode, then what it will do, it is over here when we use this mode, then it will delete the output folder or directory, and then move the data with respect to query what we have performed. Okay, so over here what we are doing, we are just like writing this particular data frame onto this particular location. This is the location. This is the location. So we are writing write mode, that is fine. So we are writing the test data frame onto this particular location. So this is the location that we are having Titanic and output. That is fine. And we are able to get the outcome, and we have utilized overwrite mode. Let me try to do the execution once again. Okay, I have done the execution of this particular file for code once again. Over here, previously it was executed at 10:44. Now, okay, now it will throw error. Part 000. It will throw error because it will throw error. Just have a look. Okay, so error is there. And error is there, fail to delete file or directory, because what is happening over here in this particular path, we were having this file which was created in the previous execution, and now once we are using overwrite mode, then overwrite mode is doing what? It is going to delete the data which is available onto this particular path and create this particular directory once again, and then load the output, load the result with respect to the query that we have performed, and we are trying to write the outcome of that this particular data frame, but a file is already available that is in use. So if something is opened in Windows, then we are not able to delete it. That is the Windows property. Yeah, let me close this. So we have closed the file from this particular location. Let me try to do the execution of this particular code, and at this moment, like we will be getting the outcome. Say this particular file will be deleted and new files will be created over here. So the execution of this code has been started. Okay. Okay, the execution has been done, and just have a look. Now we are having the outcome at 10:49 now. So overwrite mode is doing what? It is going to delete whatever is available onto this particular path and then write the output with respect to the query. Okay, then we are having another mode, that is append. Append. So append mode is when we are using this mode, then it will append the new files on given path, on given path. So say instead of this overwrite, we have used append. Let me use append over here. Append. Now what it will do, it is not going to delete the files onto the output directory. It is going to append over here only. Let me do the execution and you will see. So execution has been started. Previously the execution was done at 10:49, and these are the results with respect to the execution at 10:49, and new execution has been started. Okay, it has been done, and let me refresh it. Okay, just have a look. So we are having two files over here. One is at 10:49 and another one is at 10:51. That is the current time. So what we are able to get with respect to the append mode is going to append the new files or output onto the mentioned location. It is not going to delete what we were able to see in overwrite mode. So appending is going to append onto that particular location. The next mode is ignore. Ignore. So ignore if path already exists. It will ignore the operation if path already exists. Okay, so just have a look with respect to the ignore as well. Ignore, and let me do the execution. So execution has been started at this moment, and and so it has done nothing with respect to writing the output. It has ignored this particular write operation. We are able to see the outcome with respect to the previous executions only. Okay, that is ignore. Then the last mode what we are having, that is error mode. Error, and this is the default mode as well. Error. So it will throw error, throw error, error if path already exists. Just have a look. Let me change the mode to error and do the execution. Ignore mode just ignored the operation and it has done nothing. And over here Once we are using ignore mode, error mode, then it will throw error that path already exists. Okay, just have a look. Path already exists. We are able to get uh, that this particular path already exists, and it has, you can say, it has done nothing at this moment. Error is default mode as well. Let me mention over here default mode. Default mode. If you are not mentioning anything, then the by default error mode will be there. You just have a look. I'm going to remove this mode and we will be getting the same output. We are not using any mode operation over here, and let me do the execution and we will get the error. The same error like path already exists. So execution has been started. Okay, so what we are able to get, path already exists and it has not performed the write operation. So friends, what we are able to see, we are able to see over here, like in Spark write mode, we are having four modes: overwrite, append, ignore, and error. Error is the default mode that we have seen, and if the mentioned path where we are planning to write the output already exists, then it will throw error that path already exists. Ignore, it is not going to perform if operation. It will ignore the operation if path already exists. Append is going to append onto that particular mentioned path, and overwrite is going to delete all the data from the mentioned path and then going to create the folder and move the output with respect to the query performed. These are nothing but with respect to like modes what we are having inside the write. What we have seen, there are certain stuff like partition by. These are nothing but optimization technique. Bucket by, and compression. Compression. Okay. So once we are going to, let me try to pick bucket by and partition by clause, and then we will move with the compression. So partition by and bucket by, what is the advantage that you will get with partition by and bucket by? So partition by is mentioned over here. Partition by and say bucket by. Okay, during the data write. So what is happening, say if like I am going to write the outcome on a particular location. So this is the location where I have written the output. And onto this particular location, this can be anything. It can be a data lake, a data warehouse, database, or disk location of your local machine. It can be anything. But suppose if the customer needs to perform the queries over onto this particular data that you have given. Now say this is the data, and in this particular file what we are having almost 419 records. 419 records are there, and if the customer wants to perform the operation or queries onto this particular data and say select star from select star from this test say table, select star from test table where embarked, that is the column name over here, where embarked equal to say q. Okay, so this is the data set what I'm having, and onto this particular data set, I'm going to perform this particular query. Now, if I just need to perform this particular query, then what I need to do, I need to scan the entire file in order to get the result with respect to this particular query. Okay, it is going to scan this particular record and will check that is it like embark equal to q or not. Okay, if that is fine, that is going to take that particular outcome and then move further on to the next record. So in this particular way, I just need to scan all the records from this particular data set. So uh, scanning, if I need to scan the entire data set in the big data world, now we are having 407 records only. Now you can think in this particular way, like if you are having millions of records or billions of records and you need to find out certain values, and at that moment if you need to scan the entire data set, then that will be a time taking process. That will be, that will have high cost in terms of latency as well, and in terms of money as well. Basically, say if you are having a particular data set or database, say Athena, you are using from the AWS side. So inside Athena, what is happening, the cost or the pricing is based upon the scanning. If you are scanning huge data, then uh, price will be more over there. If you are scanning less data, then price will be less over there. So in order to boost the performance, what we need to do, we need to minimize the scanning. Okay, we need to minimize the scanning. And friends, partitioning and bucketing, these are the key you can say concepts which are utilized in order to minimize the scanning. Okay, how we are able to minimize the scanning, let me write it over here. So if we need to store the output on a location, and it is then it will be queried, it will have queries from customer side, then we need to think to optimize it. With partition and bucket, we can reduce scanning, and we can leverage these techniques. techniques. So partition by and bucket by is used to minimize the scanning. How we will be able to minimize the scanning? Because over here we are going to divide this particular data. Say the customer wants to perform the query based upon the embarked column, or based upon the say passenger ID. So we can play with these particular columns, and we can reduce the amount of scanning. So how it will be possible, just have a look. So over here, with the help of partitioning, what I'm going to do, I'm going to divide this particular data in terms of partition. And like if the query is based upon at that moment, we just need to take the input from the customer, like on which column you are going to perform the query. Say if the customer is willing to perform the queries onto the embarked column, then we need to do the partitioning based upon the column. If you are doing the partitioning based upon any another column or bucketing or any other column which is not required from the query perspective, then that will not make any sense. So we need to have the clarity for the customer input, like on which column the customer is performing the queries. So over here, say the customer is performing the queries on embarked. So how the partitioning is working over here? So let me uh, embed a clause over here, that is say model. I'm going to leverage override and partition by. We are having a particular clause partition by. Based upon partition by, I can do the partitioning and say the customer wants to perform the queries onto embarked column. Let me do the partitioning based upon the embarked column. So I have embedded a particular clause that is partition by over here. And previously what we are able to see, in this particular output folder we are having a particular file, single file. We have done the execution twice. So with append mode, one is with overwrite mode and second one is with append mode. So we are having two files. Now let me try to do the execution with partition by clause, with the help of partition by clause. So I have used partition by clause over here, and just have a look what is happening over here, and then you will see what is the betterment has been given with partition by clause. Okay, so the execution has been started, it has been completed. And just have a look over here, friends. Like if I have done the partitioning, this is the Titanic folder what I'm having, and over here output is the folder where I'm storing the output. And over here what we are able to see, embarked equal to C. So CQS, so these are nothing but the columns onto which the partitioning has been done. So if the customer wants to get the data, if the customer wants to perform this particular query, select star from test where embarked equal to q, so this particular folder will be given. And just have a look, all of these particular records are with respect to q. Okay, so previously we need to scan almost 400 records, now it is going to scan 47 records only. And you just think in this particular way how like uh, the scanning has been minimized. If scanning is less over here, then definitely this particular query will be fastened in terms of latency. Okay, it will be having low latency. And if a particular query is having less time, then definitely it will be less cost as well, less cost. Or if the amount of data is amount of scan data is less, then definitely the cost that I need to pay, that will be less only. Okay, so in this particular way, what I have seen, like fasten the query and minimize the timings, and scan the data. Okay, so the scan data has been minimized over here. And the timings, because like less data, if you need to scan less data, definitely that will have less time. and and if like the less time is there, then the query will be fastened. So all of these particular things are correlated with each other, but fasten with respect to time and scan data with respect to money. Okay, so the price is calculated based upon the amount of data you are going to scan. So in this particular way, what we have seen, like partition by clause is going to divide the data based upon the the mention column. And what is the syntax? You just need to use partition by, and you just need to give the name based upon which you are going to do the partitioning. Okay, that is fine now. So with the help of partition by clause, you are able to minimize the amount of scanning, and it has fastened the performance as well. The next clause what we are having, that is bucket by. Okay, bucket by. So bucket by, now the partition is going to give you a folder. Partition clause is going to give you a folder or directory, and this bucket by clause is going to give you a file. Bucket by clause by going to give you a file, give you file. Okay, file or files, basically based upon the number of buckets that you are going to mention. Now another concept that you need to keep in your mind, like how you are going to do the partitioning, like on which column you are going to perform the partitioning, and on which column you are going to perform the bucketing. Okay, so I'm going to cover that as well. First, like, just try to leverage the bucket by clause. So I'm having bucket by clause, and let me try to say do the bucketization. Let me open the sheet, test data, test CSV, and over here say I am going to do the bucketization based on the passenger id, and I'm going to leverage dot bucket by, and I want to have say 3 buckets, and onto the passenger id I want to do the bucketization. Okay, so in the same fashion, in partition by clause, we have mentioned a particular column, and based upon that column, the partition, based upon the records that is mentioned in embarked column, the partitioning has been done. Now over here bucket by, so bucket by clause is going to have two information. First one is how many buckets you want. Second thing, the column name on which you are going to perform the bucket by, bucket, or you are going to apply the bucket by clause. Okay, so just have a look, and once you are going to use bucket by, so save will not work. You just need to have save as a table. Let me try to run, and it will throw errors like save is not working with bucket by clause. Just have a look. Okay, so the exception is there, save does not support bucket by right now, huh? So it is not supported by bucket by clause. So what we need to have, we are having a particular clause, save as a table, save as table, and we just need to mention a new tab, huh? New tab, bucket by, that is fine, huh? Let me do the execution. So what we have done over here, we have done the partitioning based upon the embarked column, and now what I want the bucketization, but I want to apply the bucket by clause based upon the passenger id, which is a column in my data set, and I want to have 3 buckets. So with respect to the previous execution, what we are having 3 directories or 3 folders, and in each folder we are having 1 file. Okay, and over here what we are able to see, like we have minimized the amount of scanning. Say previously uh, almost 400 record was scanned. Now with respect to this particular file, say 100 records are scanned. With respect to this particular file, only 47 records are scanned, and with respect to say this particular folder, say 200 records are scanned. So we have reduced the amount of scanning. Now can we reduce it further? Yes, we can reduce it further. And how we can reduce it? With the help of bucketBy clause. So bucketBy clause is going to give you a file and multiple files. Basically, just let me do the execution, then we will have discussion. So the execution has been started at this moment. Okay, test CSV, that is fine now. And output. Okay, so the execution has been done 10:15, 10:15. Now we are able to see the date modified and the timings are there 10:15. So execution has been done. And with respect to our query, what we have mentioned, like my data must be partitioned by embarked column and it must be bucketed by passenger ID. Okay, so just have a look. So let me open say embarked, where the S info, like where records or partition S is there, and in this particular partition what we are able to see, we are having three different files, and three different files with respect to bucketization, because what we have mentioned three buckets over here. That's why like the entire records which are available in this particular partition, those particular records are further, you can say, divided into three buckets, because we have mentioned three buckets over there, and the format is CSV that we have mentioned in the code only. Okay, like format is of CSV. If like we have mentioned Parquet, so it must be in Parquet format. That is fine. So what we are able to see, we have further minimized the amount of scanning. Previously, like we used to say scan 47 records with respect to this particular column, with respect to the queue records in the embarked column. Now this particular file is having say 19 records only. Now the amount of the amount of records has been, amount of scanned records has been reduced, further reduced. Now let me focus over here. So partition has divided the data into based upon the column, and the like the number of partitions that will depend upon the categories which are available in this particular column. Say if we are having 5 categories, so 5 partitions will be there. 10 categories, then 10 partitions will be there. But over here, with respect to the bucketization, we are explicitly mentioning the number of buckets, how many buckets we want to have based upon this particular data. Okay, there are certain insights as well, like how the bucketing is working, and on which column. The question what is coming in my mind, like how the bucketization is working, like which record will move to which bucket. Okay, that is the first thing. Second, how many buckets I need to have. Okay, then can I do the bucketization based upon categorical values? Okay, these are certain questions with respect to the bucketization. But first one, like on which column I am going to apply partitioning and bucketing. Okay. Okay. So there are certain questions with respect to the partition and bucketing, like what we are able to see over here. Like we have applied partitioning onto the embark column and bucketization onto the passenger ID column. That is fine, and we are able to get the outcome. But is it the same case with each and every data set? Like what are the things, or what are the points that we need to consider in order to apply partitioning and bucketing on a particular column? So we are having certain stuffs, say on which column I need to apply partitioning. So cardinality, yeah, cardinality. Cardinality is a concept. Once you are having low cardinality, then then you will go with partitioning. And once you are having high cardinality, you are having low cardinality of a column, then you will go with partitioning. Once you are having high high cardinality of a column, then you will go with bucketization. So cardinality, yeah, let me discuss with respect to the cardinality. So low cardinality means, say once you are having unique records, say in a particular column over here in this particular data set, like unique records are almost like each and every record is unique over here. Like repetition of records is less over here, means cardinality is high over here. And once you are having, say, repetition of record is more, repetition of records is less, repetition of records is more. So repetition of records, once you are having a repetition of record more, then you will go with the partitioning. And once you are having say repetition of record is less, then you will go with bucketization. Or sometimes, like try to think in this particular, once you are having categorical values or categories, and you can do the pivoting, you can have the pivoting like output, then blindly move with partitioning. And once you are having, say, unique values, say employee ID, or unique records, basically say Aadhaar card number, okay, the passenger ID will be unique only. Or say uh, say student ID, yeah. So those particular things are the numeric one, and those are non-repeated values as well. So at that moment, where like you will not be able to apply partitioning, then you need to go with bucketization over there. Okay, so cardinality is playing a role. Like once you are having low cardinality, move with partitioning. Or like categorical values, and you can do the pivoting and all over there, so move with partitioning. Once you are having, say, numerical like stuff, and you are having unique values, more unique values, then you need to decide the number of buckets over there, and then move with the bucketization. So cardinality is playing a critical role in order to choose, like either we need to go with partitioning and uh, or we need to go with the bucketization. That is with respect to the first you can say question. Then how the bucketization will work? So by default, certain hash functions are working in order to movement of record. So hash function say if we have decided three buckets, then and we are having say 10 records. So which record is moving to which bucket? So who is going to decide? The hash function is going to decide. Hash function is going to decide the movement of record in a particular bucket. So let me give you an insight. Like say modulus division is the simplest hash function. Say 1 modulus division 3. 3 is the number of bucket over here. The remainder will be 1 only. So this will move record will move to bucket 1. Okay. Then 2 percentage modulus division 3, the output will be 2 only. The record will move to the bucket number 2. Then we will have 3, record number 3. Okay, so record number 3 modulus division 3, and output will be 0, and the record will move to the bucket 0. Okay, in the same fashion, like we are having say 4, record number 4 modulus division 3, outcome will be say 1, and record will move to one bucket, first bucket basically. And if the record number 5 is there, modulus division 3, output is say 2, remainder is 2, the record will move to second bucket. Now 6 modulus division 3, and outcome will be 0, remainder will be 0, the record will move to 0th bucket. Now 0, 1 and 2. So what we are having? We are having three buckets. Three buckets, and that's what you will be able to see over here. 0, 1 and 2. Okay, so this is the 0th bucket, this is the first bucket, and this is the second bucket. So bucket id is always started with 0 first and then second. So we are having three buckets. If we are going to say have four buckets, then in the like 1 modulus division 4, outcome will be say 1. So in that particular way, like we will be able to move the record. So these are some simple, you can say, inbuilt functions which are working in order to movement of record. Now just have a look. Once a particular person is going to perform this particular query, okay, say from select star from test table, basically where embarked id embarked equal to q, and 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 say passenger id equal to say 892. So at this moment, what will happen? It is going to first check this particular partition. Okay, so let me try to pick a particular partition, and then okay, 892. Okay, so over here, it is going to first pick the partition. Let me open this. Okay, say 939 now. 939. The query is like this. 939. Now, what will happen? So if the query is like say where embarked equal to q and passenger id 939, then what will happen? So it is going to first pick this particular column, uh, pick this particular partition, like partition q, because the customer wants the partition q. Okay, so it will be going to you can say scan it is going to this particular partition over here, like it will check, like with the help of indexing and all, it will be having the information that this 890 939 is available in zeroth bucket. Okay, zeroth bucket. And then only this particular bucket will be scanned. So previously, if we were using partition only, then the entire, you can say, file was scanned from that particular partition. But over here, what we are able to see, we have further reduced the amount of scanning, and this is like what we are able to get the betterment with respect to the bucketization. We are further minimize the amount of scanning, and that is what we want. Like we want to minimize the amount of scanning. So in the practical world, like if we have done the optimization based on partitioning and bucketing, then we will be able to save huge cost of the organization, because nowadays each and every organization is moving towards the cloud. And cloud, like whatever we are, like for the duration, uh, for the duration when we were busy onto the cloud, or we have scanned certain data, so we just need to pay with respect to that particular usage. So if we have minimized the usage, we minimize the amount of scanning, then definitely we will be able to minimize the cost. So these particular things are, you can say, applied a lot in day-to-day life, partitioning and bucketing. And then, what is the third question? How many buckets I need to have?
So I have a query here.
Mm-hmm.
This bucketing and partitioning. So in partitioning, we know that this is queue, so it is a directory, so it is directly going to that folder. But where, how it will indexing, mean where it is indexing that which partition is carrying this 939 results.
First of all, like basically, it is not like say we are mentioning we are querying based upon this. We are our query is like where embarked equal to Q and passenger ID is 939. In Q only we are having 939.
Right. But this 939,
Okay.
it has three files there. So in which file it has to search? So how it is
So so that's what like this particular indexing is working over there. This hash function is working over there. Okay, this is the simple one. Certain another algorithms are also working over there. Okay, so those particular algorithms and indexing is going to decide like this particular record is moving to zeroth bucket, first bucket, and second bucket. And once we are having that particular information, then only that particular file will be scanned. It is not like it is going to scan all the buckets and all whatever is available over there. It might be possible like you are having thousands file over there, thousands bucket. If data is used, thousands bucket can be possible, right?
right?
Okay, so these hash functions, that's why like I have mentioned certain hash functions are working, and which are deciding which record is moving to which bucket. If like I'm having the information in the very first step, w- based upon what I have decided, like this record is moving to this bucket, then uh, like I can, with the help of that particular, you can say, algo, or you can say use case, I can get like the record is inside this particular bucket. I need to scan this particular bucket only, right? Clear, Rohit?
Yes, it was clear.
Okay, okay, perfect. Now, over here, I have just blindly mentioned, say, three buckets, but say I can mention two buckets as well. Let me mention two buckets and do the execution. Okay, the execution has been started. output 10:15, 11:15, sorry. Okay, it has been done. 11:34, and just have a look. Now we are having two files, because we have mentioned two buckets. So what I want to say, how many buckets I want to have. I previously I have mentioned three buckets. Now I have mentioned two buckets. But what is the correct number? What are the total numbers? What is the, you can say, what is the accurate number? Like this much of bucket I can have from this particular data set. So that will come with experience only. That will come with experience, and your knowledge with data set. With the data set. Okay, so like, even like, if I can say, like, you can have three buckets and four buckets or five buckets or 10 buckets, that will not be the correct answer. uh, Once you are like working onto a particular data set and you are having the understanding about that particular data set, like this particular data that I'm getting on daily basis or monthly basis or yearly basis, so that particular data is having this much of record, and if I'm having three buckets or five buckets or 10 buckets, so based upon this particular number I'm having the better performance. Okay, so that will come with that particular experience. Until unless you are not playing with data, you are not, you can say, playing with the number of buckets, you will never you get the information like how many bucket you want. Nobody is going to tell you like you can have this much of bucket. It will come with experience. It will come with your understanding with the data. So once you are having a particular data set, try to play with that particular data, get the understanding from that particular data, then you will be able to get the information that how many buckets you need to have, and that is giving you a better performance. Okay, so that will come with experience only, friends. Now, can I do bucketization based upon the categorical values? Yes, you can do the bucketization based upon categorical values as well. Okay, you need to try this and try to do the bucketization based upon the categorical values. You will be able to get that particular outcome, but this is not preferred. This is not preferred. Try to move with the data which is having numerical values, and categorical values means like you are having a low cardinality over here, and low cardinality means uh, partitioning is the perfect, you can say, operation over here that you need to perform. However, if you like apply the bucketization over there, that will be working, but that is not preferred. That is not preferred. So these are the certain things. Just have a look and ask if you are having any doubt. Then we will move further with the next stuff, that is compression. All of you just have a look and ask if you are having any doubt. Swati, Rohit, Naresh, Shivam, Vandana, any confusion in your mind with respect to partitioning, bucketing, and write modes?
So one query only. Like
Mm-hmm.
when we are going for querying into the data set, okay.
Mm-hmm.
Whether there will be any metadata related to the stuff like which data is moving to which bucket, so that when the query is triggered over the cluster, it will move to only that particular file where that particular data is mentioned. So how this routing is done when any query is running over the cluster? How that
I
query
didn't I didn't get
will
your query properly. Can you elaborate more onto
okay.
this?
I'm just coming to your select query where you have marked,
Mm-hmm.
okay, the partition, the file has to be partitioned by, or embark column, where the column embark
Mm-hmm.
is having a queue as it's specified.
Mm-hmm.
So it will move to
Mm-hmm.
that particular folder which is having embark queue. Okay, that is fine.
Mm-hmm.
Till that it's clear. But then when the
Mm-hmm.
bucketing has happened, the particular your product ID is being divided into the three buckets. So how we
Mm-hmm.
will get, like, okay, this your product ID has been marked to your bucket 0. Okay, okay, this the other is marked to your bucket 1. How that mapping thing will be taken care, and how we will get, like, okay,
That
if
is
I am
that
searching
is
for.
that is based upon this hash functions, huh? That is based upon these hash functions what I mentioned, huh? Like this is the simplest one what I have mentioned over here, like how a particular record is moving. So you can think, say passenger ID 1. Okay, so passenger ID 1 is moving to say bucket 1, passenger ID 2 is moving to bucket 2, passenger ID 3 is moving to bucket 0. You can think in this particular
That
way.
is clear, sir. Like, my query is, when we are searching for, okay, can you just show me your search select query
Hmm.
in your notepad itself?
Hmm.
Mm. Yeah, yeah. Then you have mentioned, no, no, the passenger ID is 939. So I just
Hmm.
want, like, okay, when it is seeing 939, whether the hash function will again work, and it will find, okay, 939 is specified in your bucket 3, or 939 is specified in your bucket 2. Then it will move to your that bucket file. Is that so, or something else will happen?
Yes, yes. Hash function, indexing, okay, each and everything. Bucketization inbuilt is having certain indexing related stuff. Huh? If you like
Okay.
deep down inside the bucketization, it is, you can say, having the indexing as well, right? So it is having the information like in which bucket you are having which data. Okay, and like once we are having a particular data that I need to search, then it is moving with respect to those it is going to call those particular indexing and hash functions, and then it is going to fetch that particular record from that particular bucket only, right?
Okay, sir. Clear. Thank you.
Okay, so it is not like say movement of the record is based upon that. Even like once we are going to scan the data, those particular indexing hash functionality will came into the picture in order to move that particular record. And say you can think in this particular way. Data is stored say onto S3 and we are querying based upon Athena. Like if data is stored in onto S3, we will be able to query onto that particular data. So over there, what we are able to see, we are having say directories and the files. So we are going to scan from those particular files and directories are nothing but partitions, and files are nothing but buckets, right? So it is going to align with the indexing and functionality, hash functionality, in order to fetch a particular record which is being searched. Right, Swati?
Yes, sir. Clear. Thank you.
Okay, okay, okay. Naresh, Rohit, Shivam, Vandana, any confusion? Anything that is there in your mind? Huh?
Nothing.
Okay, perfect. Vandana?
Uh, no, for now, I think I'll need to go through it again and I'll have to understand it to have any query.
Okay, okay. So next stuff is compression. Okay, so what we are discussing, friends, over here, like the optimization. Now we are doing certain amount of optimization onto the data, like how we can minimize the amount of scanning, how we can minimize the latency. And in big data world, the main stuff what we are having, like minimization of the latency. We are willing to minimize the query execution time. We are like working for the minimization of the time in order to move record. Okay, we are working in order to reduce the amount of shuffling, that is the killing operation, huh? So all of these are nothing but optimization, that we are doing on to top of data. Now compression, without compression we can't think the optimization, and compression is playing a very critical role in big data world. So if we talk about compression, there are two types of compression: process time oriented and uh, storage storage oriented, storage reduction oriented, storage size oriented, I can say. So compression are of two types: process time oriented and storage size oriented. Storage size. Okay, process time oriented main focus to reduce time, and main focus to reduce the size of data. Okay, data compression. Compression basically, let me mention compression. Both of these are the compression techniques only, but one is having a motto to reduce the processing time, and another one is having motto to reduce the size of the data. Okay, or to save the to to save the disk, to save more disk. Okay, to save more disk space. But you might be thinking, like, if a data is having less size, then that will be processed with low latency, that will be processed in a faster way. But that is not true. Okay, because what is happening, if let me take an example, like if I'm having a compression technique that is process time oriented. Okay, and say initially I'm having say 10 GB data. Okay, and say I'm using process time oriented compression, and it has compressed my data to 8 GB. So 2 GB has been reduced. That is fine. Now I'm okay with this particular data. But once I'm having storage size oriented compression technique, and once this particular compression technique is working onto this particular data, it has given me the output say 6 GB. Okay, so initial data was 10 GB. Once I was using this particular compression technique, then the size was 8 GB. And once I'm using storage size oriented compression technique, then it has compressed the data in a better way. And the disk size was saved more. Over here, like it is able to save 2 GB only based upon this particular data, but storage size oriented compression technique has saved more. Both of these are the compression technique, that is fine, but what is happening, this is providing better performance with respect to execution of jobs, because compression itself taking some time. Try to focus over here. Compression itself taking some time. If I am going to compress a particular data, and I'm going to compress with respect to the compression techniques, say storage size oriented. So that particular compression will take time. However, like moment of record will be moment time. Movement of this particular data, that will be less, but this you can say compression, like once I'm going to compress the data with respect to this compression technique, that will be the huge time over here. So that's why, like what I'm having, like I'm having two types of, you can say, compression techniques. Say this particular compression technique is able to save more, but its performance is not good. Over here, like this compression technique is not able to save more disk, but it is able to boost the performance. Now you need to choose a compression technique which based upon these purpose, like are you going to save the disk, or are you going to boost the performance of the jobs. So in big data world, like we are willing to work on to the first type of compression technique, like process time oriented. We are looking in order to boost in the performance of the jobs. If like the data size is a little bit more, we can manage with that, but we just want to have fast in performance. We just want a particular job must be executed with low latency. So these particular compression techniques are being preferred. Now we are having certain compression techniques, say snappy, lzo, then ggip, bgip2, bgip2, bgip2. Okay. So these are nothing but there are many more compression techniques in big data world, but at this moment I'm taking these, you can say, four only. Snappy, and these are you can say very famous compression techniques as well. So once you are having snappy as a compression technique, just a minute. Okay, so snappy, that is, you can say, uh, hmm, performance. Let me have certain uh, categories. Say first one is say performance. 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 This is very fast. Very fast. Then LZO, that is also very fast. Fast. Very fast. Uh, and let me try to divide this. So, uh, 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 huh, category. Say, so let me mention, say, optimized for, say, optimized for speed. Same, optimized for speed, optimized for speed. Over here, this is optimized for storage, optimized for, say, space, I can say, space, disk space basically. And in the same fashion, we are having this bgip2, and this is also optimized for space. That is fine. So once something is optimized for speed, so definitely the performance will be very fast. And LZO, it is also very fast. And if we talk about this, that will be GZIP, that is gun chip basically, and BGIP2 is binary zip, and this is slow. Okay, so performance wise, Snappy and LZO, these are the, you can say, compression techniques. These are compression techniques, or we can say compression codecs. So these are very fast, ggif slow, and bgif very slow, I can say, very slow. Okay, fast, very fast, I can say in this particular way. Okay, now performance wise that is fine. Now another stuff like so if something is fast and disk space saved disk space, so I can say save disk, so less, very less, more, or you can say better and best. Okay, so if like what we have seen over here, if a particular compression codec that is going to reduce the processing time, it is going to save less space on disk. Okay, and if it is going to, you can say, have more time, and like it is going to if a particular compression technique is slow, if a compression technique is slow, then definitely it is going to save good space onto the disk. So this bgip2 is saving you can say more space onto the disk. And with respect to certain you can say comparisons, what we are having, say this gunjip that is 2.5 times better than snappy, better than snappy. And if this is, you can say, 2.5% better than snappy, means it is saving 2%, 2.5 times better space. Like if it is saving 1 GB, then it is saving 2.5 GB. Like it is reducing, it is compressing the data in a good way. Okay, so 2.5 times 2.5 times better than snappy. And with respect to performance, these are certain stats. Performance, it is 2% slower, slower than snappy, than snappy. And once we are talking about this bgip2, so bgip2 is 9% better, 9% better than ggip, gunjip basically. And if better means it is saving more disk, it is saving 9% better what the gunjip is saving. Okay, with respect to compression. If something is saving more disk, then definitely it will be slower. It is around 10% slower than than gunjip, ggip basically. Okay, slower. We are talking about performance over here. Performance. So what we are able to see, optimization, like compression codecs. Some compression codecs are optimized for speed, and some compression codecs are optimized for space. The compression codec which is optimized for space, that will not give the better performance. The compression codec which is optimized for speed that will give you fast performance, and there are certain stats as well. One another aspect is there, that is splittability. Splittability. So splittability, yeah. So this is non-splittable. We will discuss about this as well. Non-splittable, splittable, non-splittable, and splittable. So this is another, you can say, difference what we are having among these particular compression codec, and what is the meaning of splittability. Uh, so compression is nothing but like reduction in size. And in the big data world, like what we are having, we are dividing the data into chunks. Chunks are nothing but partitions and all. So once a data is compressed and it is divided into chunks, and if we need to uncompress that chunk, it must not be dependent on uncompression of complete data set. Okay, what I have mentioned over here, say I was having 10 GB data and I have compressed it, and then we are having compressed chunks, and now I need to decompress chunk. Compress chunk. Okay, if the decompression of chunk is dependent decompression of entire data set, then we can say that particular compression codec is non-splittable. If decompression is done easily without the dependency of decompression of entire data set, then we can say that is splittable in nature. Or in other words, like we can have data, we can divide it into we can divide it into chunks, then compress and then decompress, and the decompression will not be dependent on to the decompression of the entire data set. So that is the meaning of splittability over here. So the splittable file compression codecs are desired for big data world, and in the same fashion we are having splittable file format as well. We will be discussing file formats as well. File formats, we are having different file formats, and that is also a level of optimization inside uh, PySpark. In the next session we will or tomorrow we will be discussing about the file formats. So what I have mentioned, say compression. Compression is nothing but like minimize the size of the data, and minimization based upon like optimized for speed or optimized for space. Now it will be dependent on you, whatever is what is your requirement. Are you moving with optimization for space, or are you willing to save more space onto the disk? Then definitely you need to choose these particular compression codec. So we are having different compression codecs, and based upon the requirement or during the design phase, we can uh, we need to have discussion into the compression codec as well. Like in this particular format, I'm going to have my data in the output directory. So this is like a small theory based upon the compression. Let me try to apply compression over here. So we are having a particular option, and option. Inside option I can have compression, and for the compression say I am having say snappy, snappy. Okay, snappy. So this was the outcome, and let me do the execution of the code and see what is happening over here. So execution has been started. This is the output folder. 11:34. The execution, previous execution was done at 11:34. Now execution has been done at 12:04, and just have a look. And at this moment, what we are able to see, the format is snappy. So the file is in compressed with snappy codec. In the same fashion, like we can have different codec as well. Say LZ4. LZO is not spotted over here. So let me use LZO over here and do the execution. So LZO is not spotted. Just have a look. Okay, execution. Okay, so just have a look. We are having certain exception. Codec LZO is not available. So it is not spotted. So, and what are the available codecs? Say bzip2, deflate, uncompressed, LZ4, gzip, snappy. Okay, so these are the different available codecs that we can have. Let me try to use LZ4, LZ4, and do the execution. The location is not available. So the output folder has been created and execution has been done at 12:06, and the format is LZ4. Now we have utilized LZ4 compression codec. So at this moment, like data set is very less, but if you are working with huge data set and then you are leveraging these particular codecs, then with respect to size you will be able to visualize. Over here, like say file is of 3 KB. Let me use the codec say gzip, and might be like the file size is more at this moment, because sorry, less, 2 GB, 2 KB overall. Okay, because gzip is compressing in a good way with respect to the LZ4 or snappy. The compression is good in gzip and bzip too. So okay, the execution has been done. Okay, so just have a look. 2 KB. So the file size has been reduced 2 KB, and that's what we have, uh, you can say, studied over here. Okay, like Gunjip is compressing in a good way. The same data was available over here in 3 KB. Now we are able to see in 2 KB only. Okay, if we are using bzip2, that is going to further reduce this particular data. Let me try to apply the bzip2 compression codec over here. Bzip2. Okay, so let me do the execution. So it has been started. The previous execution was at 12:07. Now 12:04. Oh, it is, yes, the execution has been done. Okay, so 2 KB is there, but yes, this bzip2 is compressing in a good way. Like if we are having huge data, then definitely we will be able to see the difference in compression. And bzip2 and gzip, these are the compression codec with respect to uh, like the compression codec which are optimized for space or optimized for disk. They are saving more space onto the disk. And snappy and lz4 or lz2 is not spotted over here in PySpark at this moment, but lz4 is sportive, and that is uh, like another variant from the lz side only. So those particular compression codecs are optimized for performance, optimized for speed, in other words we can say. So Snappy and LZ4, these are providing better speed once we are going to have these particular codecs. However, they are not going to save more onto the disk because compression itself is taking some time. Okay, so that is about compression, friends. Just have a look and ask if you are having any doubt. Just have a look. Swati, Rohit, Naresh, Shivam, Vandana,
So in organizations, which technique is most used? Snappy, LZ, or
Snappy,
GZ to PJ?
Snappy. We
Okay.
are using Snappy. These are the decided techniques. Like decision is made during the design phase only. Yeah. Once we are planning to have a project, or once we are architecting a product, so at that moment these particular decisions are made, like which file format, which compression codec, what are the different, you can say, partitioning based upon which column. So these particular things are decided during the design phase only. However, like certain optimization can be done later on, but in the initial phase these are the things that we need to decide.
Okay, sir.
Okay, perfect. Now Shivam, Naresh, Rohit,
Yeah, it's fine, sir.
Nothing from my side.
Naresh.
It's okay, sir. Just it's used only for to compress the file size of the only, sir.
हाँ just to compress the files, but you need to decide, like which compression codec you need to have, right?
Okay, sir. Okay. Okay.
Perfect, guys. Let me move further with the next topic. So next stuff is order by and short. File format we will discuss later. Order by and short. So these are two techniques in order to short the output, short the outcome. So basically, what is happening? Give me a minute. Okay, so order by and short by. Now let me try to have this particular data. Okay, let me do the shorting based on this only. However, this is the shorted one. So order by and short. So what we are having this particular code. This particular code is there. And over in this particular code, what we are doing from. Okay, so we are reading the data and then we are writing the data. But what about processing? Let me do a certain processing over here. So onto the test data frame. This is the test data frame, and I want to, you can say, first of all, like we will go through with say order by. So say order by, and I just want to say order by what I can mention say any particular column. Say PC class. So this is not, you can say, the ordered one. So ordered by, and I can mention that particular class over here, PC class column basically. I want to do the ordering based upon this particular column, and I can save this, say ordered data frame, and I can store it inside this, and order data frame I can write order data frame, and let me remove these particular clause for the better understanding. For the better understanding, let me remove partition by, bucket by, and compression clause, and instead of save as table, because we have removed bucket by clause, so we are going to use this save only, and the output is say outputs 1. That is fine. So what we have done the ordering based upon the PC class, and the outcome that we are having, we are going to store that particular outcome. Let me copy this particular code and paste it over here only. So week 11, day 16, and distributed processing with PySpark 2. Okay, so let me paste it over here. That is fine. So we what we have done, we have just done the ordering based upon PC class. So PC class based upon PC class, and we are just trying to store the output. Let me do the execution of this particular code, and then we will see the output. And over here, what we have seen, order by clause. Order by clause. We have applied order by clause. So execution has been started for this particular set of code, and it has been done. And Titanic and output 1, and this is the output what we are having. Let me open this. And what we are able to see, this was the test data set, and at this moment what we are having shorted output, shorted output based upon a particular column. So definitely like this order by clause is working perfectly. Order by clause is working fine. Like we have done the ordering based upon a particular column. Now this is based upon say one column. Can I do the ordering based upon two columns? So if you want to do the ordering, if you want to apply the order by clause onto two columns, then you can do that as well. So how to do say passenger ID. So what you just need to do, passenger ID. You just need to mention two columns based upon which you want to do the ordering and all. So it will also work, and let me give the comment here as well. The order by on a single column, and over here order by on two columns, two columns. Okay, so let me do the execution. We have basic class, that is you can say first column, and passenger ID, that is the second column. And let me do the execution. So what we have done, we have done the ordering based upon two columns. We are planning to do the ordering based upon two columns. So execution has been started and it has been done as well. Okay, so just have a look. This is the output at 12:21. Let me open this. Okay, and just have a look. So certain you can say ordering has been done onto based upon two columns. But like say if you want to get the ordering based upon say this passenger ID on descending column, basically the ordering is done based upon single column only, but we can have multiple columns with respect to the ordering clause. It can have multiple, you can say, columns, and you can have certain conditions as well. Let me try to mention over here, say the descending. If you want to get a particular data set in descending order, so what you need to do, just have this particular clause and order by, and you need to just mention the order, sorry, test data frame. Test data frame, you need to give the column name over here, that is fine, and then data frame, passenger ID, okay, column dot, and now TSC, okay, TSC, that is fine. A descending order, need to use in this particular way. Okay, perfect. So like if you want to have the data in descending format and all, so you can use uh, these, you can say, sub clauses inside the order by. We are having certain stuff like descending, count, and all. So a lot of things are there, so we can have the outcome with respect to that as well. And let me do the execution. Descending, like highest will be on to the top. Okay, it will throw error because this particular file is open now. Let me close this. Okay, so execution has been done. Okay, 1224, that is fine. Okay, so we are able to see, say, with respect to say 1306, that is like PC class 1, 1303, then PC class 1. So we are able to see the stuff is in descending order with respect to this particular passenger class. And same thing will be, we will be able to see with respect to the passenger class. This is with respect to passenger class 1, say with passenger class 2. So the stuff is in descending order. Just have a look: 1298, 1297, 1293. That is in descending order. Then passenger class 3. Okay, so the stuff is in descending order. So once like we are using like say sorting or order by clause with based upon two columns, then definitely onto one, you can say, column, uh, you can use descending, or you can say uh, descending false clause. Then things will be more clear in order to have the outcome. So over here, what we have seen, order by clause we have applied and based upon two columns, and you can apply onto many more columns as well. That is fine, it will work. Now, the shorting, how to apply the short by clause. Now, this order by clause is say working perfectly over here, and same thing is you can say possible with with short clause as well. Same thing is happening with short clause as well. Let me try to comment this and paste this over here, uncomment this, and say shorted data frame. Shorted data frame. Shorted data frame, and let me uncomment it over here and say order, sorry, shorted data frame. What is the name that we have given? Shorted data frame. And same thing will happen with shorted data frame as well. So what we just need to do, instead of order by, we just need to use short clause. Short clause, and then we will be able to see the outcome. So just have a look. It will work in the same way. Short. So what we have done, like we have done the shorting based upon the PC class. Execution has been started, and it has been done as well. And see, this is the outcome, that is the execution has been done at 1228, and this is with respect to shorted. And we are having the shorted outcome. That is fine. It is working perfectly. Now let me do the execution based upon say two columns in descending order, and just instead of, you can say, order by, I'm just going to replace it with short clause. Short clause, and the data frame is there, the column name, and this will be in descending order. Okay, so that is fine. Let me do the execution, and we will be able to get the same outcome. And I'm expecting certain questions from your side at this moment. So 12:28, the execution has been started, and soon we will be able to get the output. It has been done. Okay, 12:29, and the output is based upon like sorted based upon the sorted in descending order based upon passenger ID, and like we are able to get the same output. So order by and short both are working in the same way, and we have done the shorting, or we have applied the short clause and order by clause on one column, on two column with descending clause and all, and we are able to get the outcome. Now just have a look onto this and ask if you are having any doubt. Just have a look. I'm expecting certain questions over here.
So as per the operation, this order by and sort are the same functionality and giving the same output. So is there
Hmm.
any benefit or using someone, or both are means if I used to prefer one of the best one out of these two, so which one is good in
Mm-hmm.
terms of
Okay.
or
So
latency? What is the main array?
so order by
What is the main difference means which one I can prefer?
order by and short both are providing same output, but which one we need to prefer? This is the first question. Anybody else? Anyone else having any doubt or any question that is coming in their mind? This is
So,
the first
like
thing.
order by and sort by are providing same output. Then why we are
Hmm.
having two different names? Both are doing the same thing. What is the difference in both of the
That's what we
operations?
have mentioned over here. Order by and short by both are providing same output, but which one we need to prefer? That is indirectly your question, right?
Is there any processing time or something else that we can see that what is the difference in terms of
Hmm.
benefit?
Definitely that is there. Definitely that is there. Any other, apart from this, is there any doubt? Okay, so let me move you back with respect to Hadoop world, like what is happening inside the Hadoop world, in order to give you the understanding between order by and short by clause, order by and short clause. So, say we are having mapper one, mapper, or you can say like machine one, machine two, or machine one, or let's say mapper one, mapper two, mapper three, mapper four. Okay. So this is like these are nothing but certain mappers are available, and these are working in such a way, mappers. So over here, like what we are having, say input data set, input, and what these mappers are providing, these are nothing but intermediate output, output. Then this particular output is given to reducer, and then we are getting final output, final output. That is fine. Try to just and let me mention mapper 5 as well. visibility will be good, to here to here, so this is certain input file, okay. Now what is happening over here, these are say multiple machines what we are having, and these particular machines are working onto a particular data set, and say like we are having certain numbers, 1 to 100, 1 to 100, 200 are certain numbers, and say we need to do the sorting, sorting of 1 to 100 numbers, numbers, numbers. Now what will happen, what will happen if, so these are the five mappers, and 20, say 20 numbers will be given to this particular mapper, 20 numbers. You just think like say in this particular file there are 100 numbers, 100 numbers basically, not 1 to 100, 100 numbers, and just we need to do the sorting of these 100 numbers, so input is going to these 100 numbers will be divided into these five machines. Say 20 numbers are over here, 20 numbers are over here, 20 numbers are over here, 20, and then final 20 over here. So these particular machines will do the sorting based upon the data that is available in over there. Say over here we are having certain numbers, say 1, 5, 9, 13, 0, 2, 10. Let me mention in this particular way. Say certain numbers are there over here. Let me give an example. Say 0, say 5, 2, 3, 6, 9, is 75, and say 1. So in this particular way, like certain numbers are there in this particular mapper. This is say input side, input. So the output what it will be, 0, 1, 2, 4, 5, 6. The output what it will be, 0, 1, 2, and 4, 5, 4, 5, 6, 4, 5, 6, 9, 75.
975.
Huh. So this is the output of mapper 1. And in the same fashion, mapper 2 will be there, mapper 3 will be there, mapper 4 will be there, and mapper 5 will be there. And this is nothing but intermediate output. We know this is not the final. And all of these particular numbers are given to this particular reducer. It will take the input from each and every machine, and then finally it will do the sorting, and at this moment what will we get, we will get the final output, and this particular output will be, it will be 100% sorted, right? Definitely it will be 100% sorted, all of you, definitely it will be 100% sorted, right?
Right.
Yes,
Is
yes,
it clear so far?
Yes, sir.
Naresh, Swati,
Yes.
sir, yes, sir.
Shivam, Vandana.
Sir,
Is
I
it
have a
clear so far?
question.
Mm-hmm.
For mapper 1, it is sorted. Mapper 2, it is sorted. The final output, will that be also sorted?
That is given to all of these particular machine, intermediate output will be given to reducer. That is another machine. It will consume the input from all the machines and then apply the logic and provide the final output. It will be 100% sorted. Single reducer is there over here. Right, you just think in such a way, like you are five students and you have given certain numbers, you are having certain numbers, and you have done the sorting, and based upon your output you have given those numbers to me. Then what I will do, I will definitely do the shorting, and that will be 100% shorted. Huh? Is it clear now?
Yes, sir.
Okay. Now we are having another aspect. Another aspect. So input is there, but instead of one reducer, we are having two reducers over here. Two reducers. Okay, two reducers. And two reducers. Reducer 1 and reducer 2. Now reducer 1 and reducer 2. So just think in this particular way, like Naresh, Swati, and say Rohit. So they have given input, their shorted input to reducer 1, and say Shivam and Vandana, they have given to the shorted output to reducer 2. Like they have given to Ashok and they have given to say Mohit, another person. So what it will do, what this particular like reducer one will do, it will short the data with respect to these three machines. And what this particular reducer do, it will short the input, short the incoming data based upon the data what is available over here. So like we will be able to get the final output, say final output 1 and say final output 2. So these two outputs we will get in the as an output. We will be having two files, but is it 100% shorted? This particular outcome, is it 100% shorted?
No.
No, sir.
All of you, is it 100% shorted?
No, sir.
That is what is happening inside short and order by. Okay, that's what I want to teach you. So order by is providing 100% shorted result, and it is working on entire data set. However, short close is not providing 100% shorted result, and it is working on a single partition, right? So this is the difference, friends. So short close in the big data world, like we are having multiple partitions, and partitions are available onto the executors. And once you apply short close, so it is going to short the data in that particular partition. And short is the performant one, because over here it is going to work onto the entire data set, and it will give you the 100% shorted result. Once we are having single machine only, just have a look. So once we are having single machine only, single reducer, so at this moment the short by and order by outcome will be the same. Okay, but once we are having multiple partitions, multiple machines, then short close outcome will not be same as the outcome of order by close. Order by, which is providing 100% shorted outcome, and short, it is going to provide the outcome with respect to a particular partition. Is it fine now? Are you able to understand, all of you? This is
So it
performant.
means, if I summarize, so whenever we have distributed processing system, we need to prefer this order by. Is it right statement?
Come again, come again, come again.
If we have distributed system, so we need to prefer
Short,
uh,
You need to prefer short.
But sort is
This is
not
the
providing.
performant. Short is the performant one working on partitions. Working on partitions level. Order by is
But
working
it
onto
is
the
single
entire data
partition.
set level.
But we have distributed and multiple partitions.
Yes, definitely in big data world you are having multiple partition and short is working onto the partition level and providing the output onto the partition level. Clear? Rohit,
No. My query is
what is
that
the
when we have
Mhm.
distributed system, so you are saying sort is preferable, right?
Mhm.
But sort is giving for a single partition, but in distributed system we have the multiple partitions.
So dear, the thing is that data set is manned with different partitions. Okay, different partitions. So short is working onto the partition, say partition 1, partition 2, partition 3, partition 4. Okay, so say output 1, that is the same case, huh? Final output 1, say part 1 output, part 1 say output, part 2 output, part 3 output. I have not mentioned like single partition level. It is working on partition level. Huh? So you will get the outcome with respect to each and every partition, right? The same stuff like reducer 1, final output 1, final output 2. And what is this? This is nothing but say certain data is given to this particular reducer and it has performed the operation. Is it fine? Are you able to visualize now? Is it fine?
But you mentioned in the second statement that this is not 100% sorted
Hmm?
data.
This is not
Sort is not
yes,
providing
definitely it will not
100%
be
sorted.
100% shorted because partition 1 is one output, partition 2 is part 1 output is second output. Huh? So over here the shorting, or you can say this particular output, that is nothing but the short output. You can think in this particular way.
Okay, then it's okay.
Okay, fine.
Yes.
Swati, Vandana, Shivam, Naresh, is it clear?
Yes, sir, it's clear.
Okay, perfect. So huh? What can we cover? Hmm. Just a minute.
And Ashok, one query more here. So this
Mm-hmm.
sort and order by these functions, these are same in RDD or data frame, or is there any difference? Like in last assignments or queries, we use sort in RDD. So we can use order
Mm-hmm.
by clause also in RDD as well.
Order by, I think that is not available. I need to check. I need to
Yeah,
check.
in RDD we use only sort. So whenever we have data frame, we are using order by. And I was running a program
Mm-hmm.
in data frame. So when I used sort, so it was not working at that time in data frame. And when I
Data
used
frame
order by,
over here, data frame only. Like we are working with data frame only, and
yeah,
short
yeah.
is
Now I
working.
saw that, but I was running. So at that time, sort was not working. So I'll try that again.
Mm-hmm. Perfect. Fine. That is not an issue. Mm,
So one more query here.
mm-hmm.
When we are using this data frame, so most of the time I saw that as in current example order by in bracket you have mentioned this PC class in double quotes. So it is taking that
Mm,
code. But sometimes we use COL, then in bracket we are using that column name. So
mm-hmm.
how we can decide that this schema we can use? Before
Actually,
calling.
these are the things we will be learning those particular things. No need to worry. We are having separate topics like how to work with columns. Huh? Okay. So in column operations and how to work with column, select expression, uh, creating new columns, renaming columns, and those particular aspects will be covered over there, right? So these are different techniques in order to, you can say, refer a particular column. So we will be learning, no need to worry onto that aspect. So these are multiple ways in Spark in order to refer a particular column, like with column expression, uh, with call function, okay, and just by in traditional way like what we are having in pandas, okay, we will be learning how to convert a data frame, then apply a data frame to pandas, Spark data frame to pandas data frame, and then apply operations over there. In previous session we have learned like how to convert a data frame to RDD, but we will be learning how to convert a data frame, Spark data frame, to pandas data frame for certain operations, like for the visualization related stuff. Visualization is let me try to show you something. Data visualization, let me start this particular topic and tomorrow we will cover. So data visualization, data visualization. So data visualization, so in PySpark, like we are dealing with huge amount of data, and once we have done certain operations, like ample number of operations we have performed onto a particular data. Now the data is fine tuned, and we are having certain uh, meaningful data. You can think in this particular way, you can take it in different words. Like previously you are having certain counters and all row counters, and now you have utilized PySpark in order to work onto those particular counters, row uh, counters, processing done with PySpark, and then you are having meaningful data, or in other words, like say you have processed and you are having certain KPIs. Okay, KPIs. So we, although like from the data engineering perspective, data visualization is not pretty required, because like we uh, are like taking the row counters and working in order to process that particular data based upon certain formulas and all, and provide the outcome in terms of charts or reports to the customer or data science team. And then data science team, what they will do, they will work onto that particular data and do visualization and all, and in short they need to do the data analysis over there. Data analysis. So for data analysis perspective, data visualization is required. And over here inside the PySpark, however, with PySpark as well, we will be able to do the visualization but inside the pandas we are having good functionality. Pandas are uh, having, I can say, are having better functionality uh, and support with different visualization libraries. So for this particular you can say scenario, what we are going to do, we are going to convert PySpark data frame to pandas data frame. PySpark data frame to pandas data frame. So libraries, and we are going to convert PySpark data frame to pandas data frame. Pandas data frame. So how it can be possible? Just have a look. Say this is a data frame, a shorted data frame is there, and right. So shorted data frame is there. Now let me shorted data frame. Just what we need to do, two pandas, two pandas. That's it. And say pandas df. Okay, and let me try to print type of both of these particular data frame. Print type of pandas df and print type of shorted data frame. Okay, so let me try to print the type and okay. So okay, so first one is data frame, PySpark data frame, and second one is the pandas data frame, pandas.co.frame.data frame. So the data, this particular shorted data frame is converted into, you can say, pandas data frame. Now we can you can say utilize the pandas, you can say, functionality. We can leverage the pandas functionality over here. uh, Pandas df dot describe. So this is the functionality, say, from the pandas side, and we can perform certain operations onto this particular data, and then we can proceed for the visualization as well.
So what is the use of both the data frames? Like both are data frames itself. Like what is the use case of both of them?
I have mentioned over here. So pandas are having better functionality or better support from the visualization libraries, which is not available in panda in PySpark, like matplotlib, pyplot, okay, seaborn. So multiple libraries are having direct support. We just import it and we can leverage it in order to do the visualization with respect to certain functionalities as well. So one thing, so pandas is working onto the monolithic way, and this you can say PySpark is working onto the distributed way, but we are having sport inside the PySpark. We are having pandas sport as well. So at this moment, like, we can convert the data set into the pandas data frame and leverage the functionalities or operations what we are having inside the pandas. Okay, like the indexing related stuff which is available inside the pandas, if you need to that is not available in onto the PySpark data frame. Visualization related stuff what I have mentioned, that is not, you can say, possible, that is not as good as we are having in pandas. So because of that particular reason, we can convert the PySpark data frame to pandas data frame, and we can have the visualization, we can perform certain operations over there, and we can get the outcome. Okay, and over here, like, what is happening once we are having pandas data frame, so definitely, like, what I mentioned, like meaningful results, and the data is less over here. And at that moment, we are converting the PySpark data frame to Pandas data frame. It is not like recommended. Say you are having huge data and you are going to convert it in Pandas data frame and try to perform the operations onto that particular data frame. At that moment, you will not be able to get the optimizations related stuff what you are having in PySpark. So you need to utilize, you need to use your mind before, like, conversion, and we can convert convert pandas data frame to PySpark data frame as well. So vice versa conversion is there, and we just need to take the good stuff from both of these two terminology and utilize in our coding. Fine, hope it is making sense, right?
So one out of box question. Do
Mm-hmm.
we have this visualization thing in Scala?
Scala, yes, inside the Scala as well, like, we are having the visualization related stuff.
Okay.
Okay, so we are having visualization related stuff inside the Scala. Actually, we need to just import the libraries, and we need to, like, write the code and do the visualization. We can uh, in PySpark as well, it is there, in Pandas as well it is there, but if we need to have good visualization, then definitely, like, we can move with Pandas. We can connect, like, we can have connectivity of PySpark with Power BI or another visualization tool, uh, BI tool, basically, for the better visualization. So that particular stuff we will see as well, like, to have the connectivity of PySpark and leverage these particular data frames, and then do the visualization over there. Definitely, like, visualization will be good over there, and that's that is why, like, we are having connectivity of PySpark with different visualization tools. Okay, so based upon the use case, based upon the level of visualization that you want, like, if you are okay with PySpark visualization that is provided by PySpark, you can go with that as well. And what I have mentioned from the data engineering perspective, we are not pretty looking for the visualization related stuff, but the data analyst or data scientist, they need to perform the data analysis, and because of that particular reason, uh, they need to, like, go through. Actually, what is happening, I'm taking sessions in my company as well. Over there, like, maximum strength are from the data science team. So they want to have data visualization related stuff. So that's why like I have added this particular functionality, like convert PySpark data frame to pandas and then align them to have visualization. So that is because of that particular reason, right? Okay, making sense?
Yes, sir.
Swati, Vandana, Rohit, making
Yes.
sense, huh? Okay, so let's try to do certain visualization, or tomorrow we will see. Yeah, I think it's 13:05, so we can uh, go through with the remaining stuff in tomorrow's session. Try to go through with today's session recording and all. I soon I will upload it onto the YouTube and share this particular file as well. So do practice, and if you face any issue, you can ping me directly. Thank you. Let me stop recording and then take your queries.